Okay, my name is Ralph Turner. We're at Laughingstock Farm. My wife and I operate about a 15-acre vegetable farm in Freeport. 15 acres in the summertime. We grow all winter long in greenhouses. We have 5 25 by 96 foot greenhouses. We grow specialty vegetables for restaurants and for our 130 person CSA. We heat those greenhouses with used cooking oil and animal fats that we collect from local restaurants. So this is about that project, how we changed over from petroleum fuel to what we call triglyceride fuel, triglycerides being any animal fat or vegetable oil. Back as far as about 2001, we recognized that ultimately we wanted to have an alternative to petroleum. We were looking for something that would provide both environmental and economic advantages. We looked at all kinds of alternatives. We looked at wood, we looked at biodiesel. I worked in the petroleum industry. I'm an engineer, so we looked at a lot of different kinds of process alternatives, and nothing really struck us as a viable alternative until we hit on the idea of, rather than making biodiesel, simply using the vegetable oil to heat the greenhouses directly. We actually contacted the people at McCain's up in Aroostook County and found that when they make their French fries, the used French fry oil from McCain's gets mixed in with residual petroleum fuel and burned directly in their boilers for process heat for their French fry operation in the county. That led me to look for small commercial type burners that could burn vegetable oil. We ultimately found them. We use these. These burners were originally designed by a variety of different companies to burn used automotive lubricants, engine change oil, transmission fluids, gear oils, hydraulic fluids, but really to prevent people from changing the oil in their car and dumping that oil down storm drains, which was a big problem in the late 1980s and early 1990s. The EPA provided a special exemption for those used automotive lubricants. So these burners were developed specifically to be able to recover heat energy from those products. What we've found is that with a very slight adjustment to the burner, we can use that same equipment to burn vegetable oil. We've been doing it for almost 10 years now. It's been very successful for us, and we intend to continue to do it. We got started when we came up with the original idea. We didn't have the capital to do the project entirely on our own, so we applied for a development grant from the Maine Department of Agriculture. The development grant, the premise of the grant was to demonstrate a new use of an existing commercially available technology. So we had the used automotive lubricant burners, and we had the vegetable oil, and the knowledge that vegetable oil had been used for 100 years to burn in industrial burners. We just needed to figure out a way to put the two together. And so the grant was to demonstrate that concept. We found a burner manufacturer on the internet that had done some work with this. We applied for the grant. We were successful in receiving the grant. We built the basic project, and then really we've been kind of fine-tuning ever since then. We heat currently 5 25 by 96 foot greenhouses, so it's about 12,500 square feet of greenhouse space. We heat to nighttime temperatures of 40 degrees. We burn about 10,000 gallons of vegetable oil annually to heat the greenhouses. We collect all of that oil from about half the restaurants in Freeport. So at least along the coast where there's a lot of tourist traffic, there seems to be a good supply of the oil. In the past, restaurants had to pay to have the oil disposed of. When that was the case, we started taking that oil from them for free so they could experience some benefit from the project as well. Since then, the energy value of used triglycerides has become very well recognized. the federal government has provided some subsidies to the biodiesel industry that have skyrocketed the commodity price of these materials, so that currently, where we used to be able to collect them for free, we're now paying about 75 cents a gallon to collect the oil. So if you consider that we're burning about 10,000 gallons of vegetable oil a year to heat the greenhouses, which would roughly equate to about 10,000 gallons of number 2 heating oil, the price of number 2 heating oil right now is about $4 a gallon. Our cost, including all of our labor to deal with the vegetable oil, is about $1.25 a gallon with the subsidies for biodiesel. So our cost of production, our heating cost rather, is going to be about $12,000 to $13,000 this year to heat the greenhouse, rather than $40,000 that it would be with petroleum, or more than $40,000 that it would be with, say, LP gas. So from an economic perspective, it isn't that we're saving that much money, it's that literally the economics of growing these vegetables in the wintertime wouldn't make any sense if we didn't have a relatively inexpensive alternative fuel that we can use. From the perspective of alternative fuel, consider that the 100% of the vegetable oil that we burn is renewable. There are no fossil carbon emissions from burning vegetable oil. It's 100% renewable. The carbon emissions are about 30% less than petroleum. Particulate emissions are 40 to 50% less than petroleum. Sulfur emissions are 100% less. There's no sulfur in this material, so there are no sulfur oxides that come from burning this stuff. Nitrogen oxide emissions are very similar with triglycerides or biodiesel or petroleum fuel because of the amount of nitrogen in the air. The nitrogen oxides mostly come from combusting in the presence of nitrogen, so this doesn't really solve the nitrogen oxide problems, but in every other respect it's so much better that that doesn't really matter. I'm asked often whether I would recommend this project to other people, and the answer is absolutely yes. There are some things that are currently providing a bit of a drawback to this being implemented widely. One of them is the development of a national standard specification for the fuel. Underwriters Laboratories doesn't currently list these products because there is no standard spec for the fuel. I'm working on that with a group called the American Society for Testing Materials, ASTM. We're very close to having that standard in place. Once that standard is in place, then the other limitation to getting this going is the capital cost. Once we have that UL label, then this project will become eligible for money that might be available from the USDA Rural Development Program for alternative energy projects. Once we get those two things in place, for any farm, for any people who are generally mechanically inclined, have composting operations where they can get rid of the food bits that come with the oil, and have a need for energy like greenhouse growing in the wintertime, I strongly recommend this. We've been doing it for 9 years, and we will definitely continue to do this. This is the difference between us being in business in the winter or not. If anybody is interested in pursuing this, the first caveat that I would offer is that this system is only really going to be applicable to commercial operations. So I would ask that people who might be interested in doing this for residential heating purposes not contact me, because it really is not applicable, and it's not going to meet building codes for residential applications for a long time into the future. So I'm really not focused in that direction. But if you have greenhouses or dairy barns or animal birthing facilities or anything like that that you'd like to heat, please feel free to contact me. My email address is ralph@laughingstockfarm.com. My cell phone number is 207-831-2182, and you can get a hold of me either of those ways. We have a website that is www.laughingstockfarm.com. There's a whole section on the website that describes the process, how we collect the oil, how we process it to get it clean, how we burn it, all of that. So definitely check out the website and feel free to contact me if you have any questions.